Okay, hello everyone. Again, this is going to be the second video going through the review. So first off, I'm going to go through number 18 and 19. I decided to kind of go ahead, write them out on my whiteboard. But for first one, we're trying to find out how many workers it will take to maximize profit. And the second one, we're doing the same thing. They just have slightly different numbers on it. So our wage rate for number 18 is going to be $1,000. And for 19, it's going to be $5,000. That's the main difference. And the principle we want to kind of use in this scenario is we want our marginal revenue product to be equal to our wage rate. So first off, I like to make a table. Going on from there, our goal is going to be to solve for our total revenue, and then we can solve for our marginal revenue product. So we charge, I believe, $100 for each product that we sell. So all we're going to do is multiply all our total products times 100. Going on from there, so got 5,000, 8,000, 9,600, 106, 105. And from here, all we're going to do is solve it normally. So one thing we can assume, since there is a point when we have 0 workers, we would have 0 revenue. So we just plug that into our normal marginal revenue product equation. So it's going to be 5,000 minus 0 divided by 1 minus 0, which is just going to be 5,000. Keep going on through. It's just really going to be the differences between each of these. And those are going to be our marginal revenue products. And since our wage rate is 1,000, we're going to pick the one that's the closest, and that's number 4, or equal to. So number 18 is going to be 4 workers. Going on to 19, we're going to do the same thing, but this time we have a couple differences. It's just one, the total product is 55, and our wage rate is 5,000. So we're going to multiply again by 100 for all these. And then from there, we'll take the marginal revenue products and see which one is equal to or greater than 5,000. Okay. And when we go through, we do still have those zeros up here, somewhat the last one. The only reason we have those is because since if you have 0 workers, you're not going to have 0 revenue or 0 product. Going on from there. What we notice is if we want it to be equal to or greater than 5,000, the only one that is greater than 5,000 is going to be 1 worker, and so we're going to stop after that. Okay, that is 18 and 19 right there. We'll keep moving forward. Now we're at 20. Okay. So we're going to find the marginal cost of the 20th unit. And remember, anything that is marginal is equal to change in total divided by change in quantity. Our total at 20 is going to be 17, and then there's our quantity, but then we're going to do it by the previous. So our total cost at 20 units is 17 minus our previous total cost, which is 12, divided by 20 minus 15. It's going to be equal to 5/5. So then our marginal cost at $20 is equal to $1. Okay. Next, for 21, assume that the total cost below corresponds with the cost of a monopolistic. What will be the quantity that this monopoly decides to sell to maximize profits in the short run? What is the price charged by the monopoly according to profit maximization? So what we're going to do here, we're going to solve for total revenue, marginal revenue, and then marginal cost. That is going to be our marginal revenue product. That's what it's actually going to be. So what we're going to do is we're going to take our price times our quantity demanded, and we're going to multiply those together. So 35, 60, 75, 80, 75. Going from there, we can solve for our marginal revenue product. Just a reminder, it's our change in quantity minus our change in total divided by our change in quantity. So we don't really have one for this first unit, just since we don't know at what price there will be 0. Going from there, which is going to be 60 minus 35 divided by 2 minus 1, which is just 25. Yep, 25. And then 15, 5, and negative 5. And again, that's just going back into our universal marginal equation right there. And then we could go into marginal costs. We're going to be doing the same thing. We're taking those differences and dividing them out. Got 12.5, 12.5, 15, and 15. And then again, we always want our marginal cost to be equal to a marginal revenue cost or revenue product. And if that's not possible, we want that to be greater than. So first off, we're greater, and after that we become less and less. So we're not going to do these. And so that's why our answer is going to be 3 units at a price of $25. 22 is just going to be definitions. Just remember those. 23, so considering the follow market, the world price is at $10 per kilogram of noodles, and the government imposes a $25 tariff per kilogram of noodles sold by an international seller. What is the total revenue generated by the tariff? And so first things first, we were at $10 as the world price, and then we added $25. So now we're at $35. So we went from, so we did world price at $10 plus tariff is equal to $35. And this is going to be our current price, if I can write. Current price. So we're at $35. I like to draw just a line through, and then all I'm going to do is see where it hits on those lines. And it hits at 105 and 135. And to get our total revenue, what we're going to do is we're going to take that tariff dollar amount, which is $25, times our difference in those. So 135 minus 105. And that's going to get us $750. 24 is then just definitions. move on to 25. Okay, so suppose that due to a storm, a big part of watermelon crops are lost. Additionally, suppose that certain benefits of consumption of watermelons have made many customers more willing to buy them for many different uses. Everything else remains constant. What will be the effect of those circumstances in the market for watermelons? This kind of goes back to earlier what we kind of talked about. So a storm has caused watermelon crops to be lost, so that's supplies going down. Additionally, suppose that so more people are willing to buy them, so demand is going up. And if we remember, demand with quantity and price are both going to follow suit, so they're going to go up. Supply has decreased, which is going to decrease the quantity and increase the price. And if we draw that out, we have supply, demand, and then here's our new supply. So we have supply decrease, so we move to the left. And then demand increased, so now we're here. And so what has happened is our price has increased, but our quantity may decrease or have increased. So our answer is going to be C. We don't know. And you can see, again, those prices increase, but the quantities are going in opposite directions. 26 is just going to be a definition here. And then for 27, if the government imposes a price ceiling at $39 for good E, how many units the producer will supply to the market? So it's nice enough to already have given us a line right here at a price of 39. And so remember, if there's a price ceiling, if you draw a guy, and so here's the ceiling, he can't grab the equilibrium. So just a reminder that this would be considered an effective binding price ceiling. So if we're looking at how much is supplied, all we're going to do is see where that $39 crosses the supply curve right here, and that's going to go right here. And then if we come down to our units, it's going to be 9 units. So 27 is your answer is going to be B. Moving from there, for 28, the following figure illustrates the market for good E. If the government imposes a price ceiling of $39 on good E, how many units consumers want to buy? So this time we're looking at demand. So we're going to do the same thing. We're going to look at 39, but this time we're going to look at the demand curve, which is right here. It's where they cross. And so if we go down, we see that 63 units, and your answer is going to be A. 29 is just going to be some definitions and equations. So we'll go on. So 30, considering the following table for a given company that produces cars, how many workers would this company hire if the price of a car was competitively priced at around $1,000 and wage rate around $10,000 per worker? So what I'm going to do here is solve just like in kind of some of the previous ones. We're going to do total revenue, marginal revenue, and then we already know our marginal cost is going to be this $10,000. So this is MC, marginal cost. So 0. And then they just charge $1,000 for it. So 15, add 3 zeros, and so on. From here, we can solve for marginal revenue, or I guess this is marginal revenue product. And a reminder, as always, something just to beat in your head. is anything that is marginal is change in total divided by change in quantity. So that's what we're going to solve for here. And so I'm just going to write out the answers. You can check my work, solve it for yourselves if you'd like. And we want, just a reminder, marginal revenue product has to be greater than or equal to marginal cost. In this case, our first choice at 1 like worker is greater, so is our second, but our third is less. So we're gonna not produce 3 or anything beyond that. So our answer choice here is gonna be 2 workers. Okay, so if a monopoly is in a situation where marginal revenue is lower than marginal cost, the monopoly can increase profits by what? So kind of what this is saying is, so if marginal revenue is lower than marginal cost, and I think a great way to kind of look at this is if we look at our the table above, as we see if our marginal revenue product is less than, what do we have to do to become greater or equal to? We have to reduce the quantity. And another way to think of this is if we have our supply, if we want to reduce the quantity as the supplier, we need to shift it here. And what does that do? It increases the price and reduces the quantity, or answer choice A. Now 32, if monopoly is in a situation marginal revenue is 30 and marginal cost is 30, the monopoly can do what to increase profits? So if marginal revenue is equal to 30 and marginal cost is equal to 50, this is pretty much the same thing. 30 is less than 50, so that means marginal revenue is less than marginal cost. And if we want to do the same thing, which is pretty much just put numbers to 31, we want to increase our marginal revenue. How we do that is we can reduce the quantity and increase the price. Okay. The following figure shows marginal cost, average total cost, the demand, and marginal revenue for a monopoly. If a firm sells 20 units, what is the economic profits? So first off, one thing I want to say is defined, it already tells you what the quantity is, but if you're looking at a monopoly graph like this, you always want to produce at a quantity where MR, or marginal revenue, is equal to MC, but you sell at a price along the demand curve. And what that kind of tells you is you see where marginal revenue and marginal cost meet right here, but we're going to actually sell at this $45 price point right here. And along with that, if you remember, our profit equation is profit is equal to price minus average total cost times quantity. If we just plug in the numbers we have here, which our average total cost is 35, we're going to do our price that's along the demand curve, which is $45, minus our average total cost, which is going to be 35, times our quantity of 20. And when we do that, we should get an economic profit of $200. All the way until 37, so 34, 35, 36 are more definition based. Feel free to go through those. But we'll move on to number 37 for some math here. Okay, 37. A firm sells a product on a perfectly competitive market. The market price of the product is $20. If the firm produces 500 units, the marginal cost will be $20. The minimum possible average variable cost is $10 if the firm wants to maximize profit. So first off, there's a couple things going on here. If you remember where we shut down, that's going to be if our average variable cost is greater than our market price. But what we're going to do here is what this question is kind of asking is if our marginal price, which is also just another term for our marginal revenue, we want it to be equal to our marginal cost. So our market price is $20. Our marginal cost is $20, which means we should produce the 500 units, which is where those are equal. Okay, that's going to be it for this video, but we'll go through 38 and the rest of them in the next.